about 3 years ago, I had the equivalent of a religious conversion, which you might have seen in some people before when they discover a new technology and they become a zealot. They proselytize. They go out knocking on doors, effectively trying to tell everyone about their favorite technology and how it's going to solve all their problems, and they become really annoying. But there are some nice things that go along with religious conversion experiences, like miracles and ecstatic experiences and speaking tongues. But I started going out, talking about it. I figured it was a good way to learn. And then when React came along, there was a Clojure script wrapper to it. So Clojure is a language that usually runs on the JVM, but also compiles to JavaScript. So I was able to work with React well to build user interfaces. This is something I started doing a lot in my spare time and working on. And then also just various open source things and trying to like cram it into my work at Zendesk where I was working. But like for the most part, my day-to-day job was maintaining like 5-year-old Rails code bases. They were huge, and I wasn't having a very good time, especially at the interaction between the JavaScript and the Rails. I don't know if you can read that, but it's pretty much how I was feeling at the moment where I decided to quit Zendesk, which was soon around the time I met this guy called Matt Dyer, who started a company called Eat Now that does food delivery stuff. He just sold it to Menulog, and was looking to do his next thing. And I was trying to sign him up for a business that I'd started, which was the Love Bot, and it would send flowers and gifts to your boyfriend or girlfriend or wife or mother, just like sporadically and spontaneously. Just trying to like automate love, basically. Yeah. The biggest problem was that people would get found out. That actually happened with Matt, the guy I was having coffee with. So he instead convinced me to do a health and beauty business. So like bookings for massage places and fake tanning salons and hairdressers and so on. And my only condition was that I got to do it in Clojure using the technologies I wanted to. So Clojure on the server side, on JVM, Clojure script in the browser, and then Datomic, the database as well, which if you don't know much about it, it's worth looking into because it's interesting. And then we're also joined by this guy who handles all the sales and business stuff. And I was kind of like, I'd always felt weird about when you do a startup, you have to like find businessy people who go out and do business and sales stuff. And I was always worried about interacting with those people because I never liked them much from when I've met them before. But Nathan's great. He's a mechanical engineer, and he flies. He races drones. Those are goggles, and he's racing them in his spare time. Anyway, so that was about 9 months ago, and I just set to coding by myself. I live on a boat. That's my mum on the boat saying hi. Yeah, it was basically just like me coding for months and months and months, building out the product, working too much, burning out, working too much again. I didn't let myself cut my hair until I could cut it through the platform. Like I could book a hairdressing appointment and get my hair cut. I kind of regret that. Yeah, but we got a product. It was out there. It was working. Yeah, we were called Bookersalon. We've now renamed to Bookwell. It basically consists of two parts. So the one part where like customers go in and book things, and then the part where salons can manage all their appointments and their employees and reporting and so on. You can tell which one has been designed by a professional, and it's not the one that I did. Yep, so it's out there in production. I got my hair cut. Now, this is the real meat of the talk. So SEO is really important to what we're doing. At Menulog and Eat Now, which are like similar business structures, something like 70% of all their traffic comes via Google. And so it was critical that we got SEO right from the very start, which is sometimes hard to do with JavaScript-heavy apps. Just because you have to please a black box. Like in our case, mainly the Google bot. We don't know exactly how it behaves or the kind of things that it likes. We have to be careful about that. For example, these are the kind of things that you want. Can anyone tell me where I'm supposed to put the hyphen? I seriously spent about 20 minutes just staring at this slide, I just couldn't work out. Is it fast server response time or is it fast server response time? Just no hyphens at all, just like fast server response time. All right, yeah. I learned something today. Some of these things are hard to do with a single page app because, for example, with navigation, there's different ways of doing it. Some people use fragments after the hash. Some people use HTML5 push state. Basically, like when you're navigating around and you want the back button to work, but you're not actually getting new pages, it can be tricky, especially when the person using it isn't a user but is a bot and might have weird assumptions about the way navigation works. In some apps, when you navigate between different screens, you're not actually clicking on an anchor tag and going to a new page via href. It's just doing stuff via JavaScript, which can be terrible for someone crawling your site because they can't work out the structure of it. They can't look at a page and say, this page links to other pages via the href. They would have to do some magic around clicking on all the stuff in your app and then examining what content changes. Do you know what I mean? Okay. Yeah, and there's also, if it has an idea about what's supposed to be on a particular page, it might be different if they've browsed there or scrolled there or something like that compared to when it's just directly fetched based on what's coming back from the server. So a lot of apps, this is the way they bootstrap, they load up. They just send back a skeleton HTML, and it pulls in some JavaScript, and then that gets parsed. And actually, I think I have it on a slide. Yeah. So it's a lot of things to happen before you actually get content back. A lot of things can go wrong in those steps, and it might be hard for the Google bot to be able to work out what is actually supposed to be seen by users. Oh, and then there's also a performance side of it as well. This is something we faced a lot at Zendesk, where it was initially that single page app that loaded up like from a skeleton. There's quite a bit of lag. I think Twitter used to do it as well, and people would complain all the time because it would take seconds before you were able to see your content, which sounds silly, but it actually feels bad to be waiting there for seconds to get the things you want. But at the same time, there's huge advantages to using single-page apps, especially around deduplication of logic at the presentation layer. Basically, like if you want your app to work like from the server side without any JavaScript, but then also with JavaScript in the client, there's going to be a lot of duplication, especially if you're using two different ecosystems in the client and the server. You're going to have different libraries for date times and internationalization, all that stuff. So what we wanted was a single-page app that was crawlable, and where if you hit a URL, you got back exactly the same thing you would see if you would browse there through the app by navigating, clicking on various things, searching. So there are potential solutions. One is to just to be like very rigorous about making sure that your server-side presentation layer is identical to the one in the client. So you have your Rails templates or Spring templates? Does Spring have templates? Is that what they call it, or a view layer? Is Spring a web application framework? Oh, thanks. Okay, the problems with that though is that you're basically maintaining two copies of the same code base. Another solution is what people are calling universal JavaScript, which is where you use React to render HTML and send it back. You render it on the server, and you send it back to the client, and they get it instantly. It's just something that's built into React. It's quite easy to use. It's a single function. You just pass it the thing that would normally render in the browser. You just take the thing that would normally render in the browser and like call it on the server, and it turns into HTML. Oh, there it is. I probably wouldn't have gone with it unless it had been used in production quite a lot. And it's not just these guys, but also Seek. Seek.com.au has been using it heavily and having a lot of success. And it seems mature and robust enough to go with. But the problem then becomes, how do you run your JavaScript on the server? The default choice is Node.js. I had problems with using this, probably because of this. Surprise. Clojure runs on the JVM. So I didn't want to be having two ecosystems and have to manage them. So there was the JVM and all the package management stuff that goes along with it, and Maven and so on. And then there was also Node and NPM and that entire ecosystem of different libraries and different tools. I would have had to learn those and make them interact with each other. There would have been lots of potential problems. When I worked at Zendesk, we had dedicated ops people. And so this is something that I would usually not think about. Like I remember when I was going around trying to get everyone to use Clojure at Zendesk, and I would just kind of like steamroll through the complaints from the ops guys because they'd be like, well, we don't have the infrastructure for that. We'd have to start running the JVM in more places and blah, 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 blah. I didn't care that much, but now I kind of understand because I've had to do this myself for this product. And I realized just that the amount of work and hassle that goes into deploying things and logging, and actually I think I probably have it on a slide. Yeah. Just all of these things I would need to think about hard again if I was introducing a new ecosystem. That's a lot of stuff. Sorry, that's a really bad slide. Important. 1, 2, 3. I'm being a bit facetious here, but one of the problems I've had with trying to convince people to use Clojure or with hiring is that people's impressions of Java are sometimes negative. Like there's a branding problem just because of maybe Java was ahead of its time in the 90s and it attempts to do web applets and stuff. And then some of the bad UIs that came out of it originally. So I've never had to do Java before. At Melbourne Uni, they don't do it. There's this guy here, the kind of people they have at Melbourne Uni. He invented his own programming language and then refused to teach anything but his own programming language, which he spent decades on in a basement at Melbourne Uni and has never seen practical use anywhere. And he was eventually fired for it. I was searching for him because I remember Zoltan. And the only reference I could find to him was in Google Books. They've eliminated Zoltan from the internet somehow. So actually, if anyone has their drinks, I wouldn't mind just having a quick toast to Zoltan. But I love the JVM. I think it's awesome. I wish that it didn't have, like, some people weren't turned off by it because it's not sexy and fashionable, you know? Just because it works so well. It's just fast and stable. There's so much tooling for it, so many libraries. I've really enjoyed getting into it as a result of working with Clojure. Oh, I use IntelliJ, by the way. There's a plugin for it called Cursive, specifically for Clojure. And yeah, I've been using Vim for maybe 10 years, and this finally pulled me away from it. Just the tooling is so good, you know? So much better than it was in JavaScript land or Ruby land or Python. Yeah, and then I don't know if you guys remember this thing that happened maybe a month or two ago where someone pulled down a library on the Node package manager and it took down all these production services because all of a sudden they weren't able to get the library they wanted, and it was just a bit of a clusterfuck. Excuse me. Right? Yeah, like they probably dealt with these issues in 1996. The people who were working on whatever Java package management systems they had back then, right? There's advantages to being mature and stable. Actually, okay, I've forgotten why Bill Murray was there. Maybe it's just a celebrity endorsement. I figure you guys like him, and you'll now associate him with me. It was probably a Groundhog Day thing. It was probably like, I would have been stuck in this loop of just dealing with DevOps constantly. So, Nicehorn. Some people say Nicehorn. I've heard the people who work on the team saying Nicehorn, and they're Americans. And it comes from the German word for rhinoceros, because Rhino was the previous way of running JavaScript on the JVM. And the Germans call it Nashorn. Sounds a little too much like Arshorn. And also, I think there's a reason we fought World War II. And it's not so we could be speaking German when we mean to say rhinoceros. But this is how it works. the syntax might throw you briefly, but in Clojure, this basically translates into Nicehorn.eval and then passes in some string, and then the return value is a nil, which is equivalent to Java's null. So in this example, I'm saying to this Nicehorn object that I've instantiated earlier, this is an object in JavaScript, and then I can say to Nicehorn, give me it back. It's actually returning the equivalent data structure in Clojure, which is it's called a hash. It's probably represented by something like a hash map underneath on the JVM. But the point is that it'll do basic type conversion between what JavaScript is doing and what Java expects, or even all the way up to Clojure. And then also, like, you have all the quirks that would normally come with doing JavaScript. I don't know if you guys know about JavaScript's implicit type conversion, but in this example, if you, like, say you opened up a console in the browser and you typed in 0 plus the string 123, you'd get back the string 0, 1, 2, 3. So you get the quirks that come with JavaScript because it's like a full implementation of the language. The only thing it doesn't have that browsers would have would be things like network access, XML, HTTP requests, cookies, just anything to do with the window style, that sort of stuff. The things that it doesn't really make sense to have on the server. So when we go to render the app, this is all we do. We take in the script that would normally run in the browser. We just tell Nicehorn to evaluate it. So Nicehorn's a JavaScript engine. It's just like typing it into a console on the browser, but on the server. We take the whole app and we just say, please render it. And then it spits back the HTML that we care about. It's slow. This is one of the worst things about Nicehorn. One of the things I really hope they try to fix, because it's compared to a browser, it's extremely slow, as you can see. V8 is that what's used in Chrome, or it's at least what's used in Node.js, right? Which has a reputation for not being the fastest thing in the world. And then there's also this problem of having to warm up. So when I restart my server and I instantiate Nicehorn for the first time, the JavaScript engine, it'll be really slow briefly until it can do whatever sort of like hotspot just-in-time compilation magic it's doing, until it can warm up. But this is actually okay. I'll show you a demo later on. It's fast enough for our purposes. Like, there are more important things than raw performance, and you can work around it by having faster servers and being clever in your caching and writing performant code. Things like all the stuff I mentioned before around tooling, actually a lot more important to me than reducing response time, even by a factor of 2. And there's also some really cool stuff we can do. Jeez, look at this. Okay, so there's the when we render on the server, we need it to get the data it needs. So, say you're showing the page for a particular salon. It's going to need the name and the different services that salon offers, and so on. And in the browser, it would usually make an AJAX request to get those things. And you could imagine on the server side, getting the things you need from the database directly and then passing it down into your templates. That's how you'd normally do it in any given web application framework. So you wouldn't be, making requests to yourself or anything like that. You'd just be getting the data you need and passing it down through. Problem we faced with that was that there's quite a lot of duplication in the code that will fetch things from the server via AJAX in the browser, and then the code that will pass it down into the templates on the server. And we managed to eliminate that by having Nicehorn pretend to make requests to the server, but it was actually just calling Java methods. So with Clojure, we defined these functions that were just static Java methods. And then from within Nicehorn, within the JavaScript that was compiled from Clojure script, we're able to make calls out to those Java methods. And those Java methods are dealing with database access. And they're doing it in the same manner that they do when they're handling requests from the browser. So this is one of the few places where we're using anything close to being advanced interrupt techniques. I think Con is going to show us cooler stuff, because I haven't delved that deeply into it, because I haven't needed to. For the most part, it's pretty simple. Yeah, I do. So here's the homepage. It's like it comes back fast, right? Like it's, even though Nicehorn is slow supposedly, this is a misleading example. The homepage is actually cached, so that's a cheat. But if I take a Salon page, it's not cached at all. It takes a little bit longer, but still enough that it feels good. So here's the site. As you can see, I can click around like it's, because it is a dynamic app, it's a single page app. So when I navigate or go back or anything like that, it's all being handled in JavaScript. It's not doing new page refreshes. So when I click on that, for example, and you can see that the user experience is quite nice in terms of performance. Obviously, it needs some design love. Like it's kind of ugly at the moment, right? But it's really quick to go through and book. And the neat thing is that if you refresh, say for this one, it's identical. Like you can't tell the difference, or at least I hope we can't tell the difference. So when I'm refreshing on that, it's sending down the HTML that's needed to make it look identical, to as if we just browsed there. And if it's not, it's a bug, and please tell me. Because Google cares about that stuff a lot. Some of the slight problems we had were some of the libraries in the JavaScript ecosystem, or specifically the React ecosystem, which we had used to render UI components. So for example, we didn't want to do our own combo box, you know, the one where you can type into it, but it's like a drop down, it does autocomplete, that one. We didn't want to do it ourselves, and there's already a great library for it. And so we just imported that. But it was expecting there to be 5 minutes? Thanks. It was expecting there to be a window, you know. So some of them just like grew out of people who are only using the browser, and they weren't expecting the JavaScript that they wrote to run on a server. But you know, this is frowned upon, and it's changing, and got the PR accepted, and now it doesn't do that. Basically, React has a concept of life cycle, and actually, it's not really relevant. And the way we fixed it was just by shimming out those things, by saying, "All right, I'll give you a window, but I'm just going to stub out all the functions in it so that it doesn't really do anything." That's a quick hack, and it worked. Obviously, the better thing to do is just to get a PR merged upstream. Another thing that we didn't really like is the stack traces and the error messages were pretty cryptic, especially for the JavaScript that had been compiled and that we were running on the server. So we take the Clojure code, which is a Lisp. I haven't even mentioned that. And it compiles down to JavaScript and then gets minified. It actually goes through Google's Clojure compiler, spelled with an S. I think the thing they wrote when they were working on Gmail, when they wanted to compile Java to JavaScript to make single-page applications. I think Gmail still uses it. How did I get to there? Oh yeah, it does all sorts of advanced compilation stuff. It'll actually, say, eliminate dead code. It'll be able to look at a function and see that it's not called anywhere, and just remove it from your JavaScript. Because it matters when you're sending it down the wire to a browser, especially on a phone. You want to eliminate as much dead weight as you can. So it's when you have, but the problem with that is that it really mangles your code, right? It doesn't produce things that are readable. And if you're getting those in a stack trace with some error that a user has just reported, like half an hour ago, I got a phone call because someone was getting some error and it was inscrutable, and the stack trace was long and confusing. And like I'll probably spend a good portion of my morning tomorrow like decoding it. So there are disadvantages to doing this to doing this interop and merging the two languages together. So you get some benefits, but there's still some real problems aside from the performance. But it's working pretty well. We wrote that like interop code and just the basic rendering stuff and dealt with all the shimming issues, and we just have barely had to touch it, which I think is a good sign. Hopefully we don't have to touch it more. We hired a guy and he's like had little trouble getting up to speed with it. So I guess what I'd like to get across through this talk is that if you use one of the JVM languages, whether it's one of these experimental ones or it's Java, you can still have single-page apps. They can still be crawlable. You can still have good user experience and performance, and also the SEO part of it through using something like Nicehorn. If you want to have React in the front end and also do it on the server, you don't have to use Node.js. It would be a huge turnoff. Like you could imagine trying to pitch that to someone at your work, and the bit where you're trying to like hide it, you're like trying to pretend that they won't have to, build out an entire new infrastructure around this new ecosystem. You're selling all the advantages, and then at the end you slip in like, oh, and by the way, it's got to run on Node.js. It's not a good situation, right? It makes it a hard sell. But this way we can keep every single thing within the JVM and use the same tooling, etc. I'm lonely. Come and be my friend and talk to me. There's a nice meetup, a nice small meetup. CLJML. It's the Clojure meetup. It'd be lovely to see you there. Thanks very much. Thank you.